We did up to AlCl3. I feel so.
Yeah, sir. Yes.
Okay.
Okay. Okay. Sure.
So AlCl3 is Lewis acid or a Lewis base?
AlCl3 will be your base.
लास्ट लाइन क्या लिखा है? लास्ट लाइन क्या है?
लास्ट लाइन वही AlCl3 का ही लिखा था.
क्या लिखा था? डायग्राम ड्रॉ किया था, फॉर्मूला लिखा था.
हाँ, फॉर्मूला नहीं लिखा था. नहीं, उसका लिखना बाकी था.
ओके, तो खाली ये स्ट्रक्चर बनाया था AlCl3 का.
हाँ.
ओके, सो उसको हम क्या बोलेंगे? सी बेसिकली व्हाट डू वी सी? वी सी दैट कि AlCl3 है, ये एग्जिस्ट करता है एज डाइमर. ओके, तो डाइमर होता है, देन ओनली इट इज एबल टू अचीव द ऑक्टेट. You can say the octet of electrons. And therefore, this AlCl3 is what? It is largely covalent. So it becomes covalent when it reacts with non-polar solvents. What are non-polar solvents? Non-polar solvents are like benzene, C6H6. Okay. Okay.
Okay.
So how will you form this structure? Al, 2Al, we will have Cl. It is what? AlCl3 now. So this Cl will bind with this Al, and Cl of number 2Al will bind with this. So it will form a covalent bond. But what happens? When dissolved in water? When dissolved in water, the high enthalpy of hydration is, you can say, breaks down. The high enthalpy of hydration, it breaks down covalent bonds.
Yeah, Jordan.
Okay.
Okay. Okay.
And it breaks down this dimer. AlCl3 is what? Dimer, because two are combined together. It breaks this dimer into aluminium It is called as aluminium hexa aqua. It is a coordination compound. Okay. And along with that, there is a release of 3 chloride ions. And at low temperature, AlCl3, it exists as a closed packed lattice of chloride ion with Aluminium ion occupying a octahedral holes. So this is neat question. Ki crystalline AlCl3. Crystalline AlCl3, it exists in the form of AlCl3.6H2O. And when you heat it, now very, very important. On heating, now this is again assertion and reason question. On heating, it cannot give anhydrous salt. Like, MgCl2 dot 6H2O. So if this dot, what we saw till now, we saw that any salt, you can say water of crystallization, whenever you will heat, what it will give? It will break down and it will give anhydrous salt,
Yes.
right? But here,
Right.
aluminium and magnesium, MgCl2.6H2O and AlCl3.6H2O, both of them, they are having digonal relationship. Okay, so both of them, they cannot give anhydrous salt. So AlCl3.6H2O, on heating, it will give aluminium hydroxide plus 6HCl plus 6H2O. And this aluminium hydroxide, again on heating, will give alumina plus 3H2O. See, this is the nature. This is the nature. So here it is not giving. So what we see that this anhydrous compound, how it is prepared. Got it?
Got it. Got it. Yeah, teacher, done.
What we see that the anhydrous compound, how it is prepared? You take aluminium and pass chlorine gas over it. Now this chlorine gas should be dry chlorine gas, and it will give AlCl3. And even you can take alumina plus carbon and then pass chlorine gas. It will react to form AlCl3 plus carbon monoxide. So aluminium chloride, here basically it is mainly produced using exothermic reactions. Exothermic reaction of two elements, aluminium and chlorine.
Okay.
So AlCl3 in solid state, it acts as a closed packed layer. It acts as a closed packed structure. Okay. But when it is in liquid state, it exists as a diamond. Got it?
Got it.
Now I'm sharing you some important property of group 14 elements. Okay.
Okay.
Just write it down. Yeah, received, Neil. Write down, please.
Yeah, teacher, receive.
Simultaneously, I'll explain you also. Okay. See,
Yeah, teacher.
basically, so if you say carbon, write down also and just listen also. Carbon 14 element. It will be S, C, G, Suno, Rakhu. Carbon, silicon, germanium, 10, lead. So when we are going down the group, on going down the group, metallic character decreases. See, carbon and silicon, both of them, they are what? They are non-metals. And germanium, it is a metalloid. What is a metalloid? Metalloid is semi-metals. Okay. And lead and tin, they are metals. Now, next we see about the oxidation state. Oxidation state of carbon and silicon
Teacher,
is what?
teacher,
Huh? Yes.
not done writing that slide. I was writing this first photo that you sent.
No problem. I'm explaining that only.
Okay. Okay.
I'm explaining that only.
Okay, teacher. Teacher, you can explain. I'm done writing that. A group 14
Yeah.
elements.
Yeah. Next, oxidation state. Now, what is oxidation state? Oxidation state may mean about the loss of electron. So carbon and silicon is having +4 oxidation state, and for germanium, tin and lead, they have a value of both +4 and +2. Why? By inert pair effect. You have to write this one.
Yes.
Okay. Now, next is catenation. Now, what do you mean by catenation? Catenation means the ability of the carbon atom to link, to share, and to form long chains. Now, why it is possible? See, it is possible due to smaller size. Smaller size is there, and along with that, you have high electron negativity. So what is it? Due to smaller size and high electron negativity. But when we move down the group, on moving down the group, this tendency of catenation decreases. So we say carbon is more than silicon, is more than germanium. Germanium and tin, they are same. And this is more than lead.
Yeah, teacher, done.
Now, catenation. Now, do you know that carbon exists in two forms?
Diamonds and graphite, salad ropes.
Graphite and yeah, the diamond and graphite. So I have shared you that also. Write down the differences. You know, but I want you to write the theory also, so that when you revise, you don't have any issue. Now I'm putting
Okay.
one question. Yeah, ma'am will share you. Which of the
Same.
following? Write down. See this question first. Which of the following does not show electrical conduction? First, diamond. Second, graphite. Third, potassium. And fourth, sodium. Yes, give me answer to this.
Diamond.
Hmm.
Yeah, teacher, diamond.
Diamond. Yeah, correct.
So
Written.
no, sir, not written. Yeah, sir, done.
Okay. So now, if we talk about, uh, we are considering carbon family, right? So
Right,
this
right.
carbon family, yeah, the elements of carbon family, they tend to be fairly unreactive. Number one. and the elements, they form covalent compounds. Number 3, see, in this case, you have to see that tin and lead, both of them are ionic compounds, right? Tin and lead, they are ionic compounds. So if we talk about this, so their configuration will be how much? NS2 NP2, right? Outermost will have this, whatever the electron is there, the number of shell is there. Second, the carbide forming. Carbides, why? Because carbon is the most easily available resource on the Earth's surface, right? So therefore, this carbide, in this, carbon combines with other elements and forms carbide. What is carbide? Carbide, you can say, is, can you tell me the formula for, have you written?
On the last statement.
Oh,
Yeah, sir.
yeah, you have to tell me the formula for aluminium carbide, beryllium carbide, silicon carbide, and boron carbide. How will you make, what compounds will be formed?
Uh, or aluminum, it will be, I think.
See, aluminium is +3
NC2.
and carbon is +4. Cross कर दो ना.
Hmm.
Al4.
Al4 AC3.
अब ऐसे ही करो दूसरा. Written?
Just
It
one
is.
second.
हाँ. Written?
Yeah, teacher, written.
Okay. So beryllium is Pe2C, silicon is SiC, and boron is B4C. Right?
Right, right.
Okay. Now we'll see about silicon. Now silicon is very important. You know, this silicon is most importantly used in current world. The use of silicon has increased. It is used in for kitchen instruments also. It is used for like in the whenever there is sliders, we apply silicon. Everywhere silicon is available. So what are silicons? Silicons are organo silicon polymers. Okay, and are formed by hydrolysis of R2SiCl2. Okay, so when this RSiCl, and R, okay, it's R2SiCl2. When it reacts with water, it will form what? OH, OH, R, R. Written. Again, when you heat it in presence of water,
Okay.
now it will again form a linear structure. This is called as linear silicon when it reacts with water. And it will continue. This is called as what? Linear silicon.
Yeah, teacher.
Written? Okay. Now,
Written.
where are they used? Where they are used? It is used in lead pencils. Now, this lead pencils which we use, it contains graphite. Second, for non-stick pans. Non-stick pans, they have a Teflon layer. on its surface.
Yeah.
Teflon formula is single bond. You have to write this way only. Single bond CF2, then again this and N. Then silicon is used as a semiconductor.
Yeah, teacher. Done.
Hmm. Now we'll see the chemical properties. I'm sharing you the chemical properties. Okay. You know, carbon is a reducing agent. What do you mean by reducing agent? Reducing agent means it reduces, it takes away the unwanted stuff. So we use carbon in all its sense. Check. मैम ने भेज दिया.
Just 1 second. चेक कर रहा हूँ मैं.
भेज रही हूँ मैम, भेज रही हूँ, 1 मिनट.
ठीक.
हाँ मैम मिला.
Oh. Neil, I think ma'am has informed that I'll be shifting class 15 minutes ahead.
Yeah, sir. I know.
You're comfortable, na?
Yeah, sir.
8:45. Okay.
Yeah, yeah.
Okay.
Yeah, teacher, done.
Okay. So this water gas is very important. How water gas is formed? Water gas, you will always use red hot coke. Okay. So
Okay.
combination of CO plus H2. You both of this, that is called as water gas. And we say that another is producer gas. This is a neat question. Therefore, producer gas take carbon, take oxygen in presence of nitrogen. It will make carbon dioxide. So what is the difference? Here hydrogen is released, here nitrogen is released, here carbon monoxide, here carbon dioxide. So therefore, this is called as producer gas.
Hmm.
Then carbon is a very strong reducing agent. Reducing agent means what? See, when we see this carbon, when it is reacting with H2SO4, what it is reducing, it is taking away. So you are getting carbon dioxide, SO2, H2O. Similarly, it is with nitric acid. Okay, and when carbon is acting as an acceptor, means when it is taking when it is taking oxygen from any oxide, you will get carbon monoxide. See, when it is acting as a carbon acceptor, you will not get carbon dioxide as a byproduct. Okay, and in the case of laboratory, how you are going to make this? You will make this by reacting. You take this acid, formic acid, and you dehydrate it. Now, what do you mean by dehydration in this case? See, we are taking strong acid, that is concentrated acid. Strong acids, they act as a dehydrating agent. They take away the water content from it, and then you will get carbon monoxide and water. Okay. So
Okay. Okay.
therefore, these are the various methods. Now, next is if we take carbon and see this carbon, it does what? It oxides of heavy metal. Okay. Heavy metal, like you can say zinc oxide or you can say iron oxide. If you take any of this, what you will get? Carbon monoxide will be evolved. Okay. Plus, in this
Okay.
case, metal will be obtained. Similarly, we have potassium ferrocyanide. When this reacts with H2SO4 plus 6 molecules of water, what you will get? You will get K2SO4 plus FeSO4 plus ammonium sulfate plus carbon monoxide. Now I'm sharing preparation of carbon dioxide. Write down fast.
Okay. Yeah, teacher.
Written.
No, teacher, I'm writing. Yes, teacher, done.
Okay, fine. So we'll continue in next class. Okay,
Okay.
bye.
Bye, teacher.